So with daymap, we've got there what you're meant to be able to do. Yes, apply. We're going to just remind you of some basics to make sure that you're on it. If you want to do some extension work, then it's in the OneNote stuff that we can play with. But for today, if you go into your OneNote, once I finish, you're going to have to just complete this little thingy. So it's in daymap, but it's also in OneNote. It's probably easier to see in OneNote. But let's just recall, because we've had a big weekend. So the hardest, I think, the hardest question that you could probably get is that one up on the board. And do we think it's hard? No? Why? So some people are going, so we don't take pictures, by the by. Never. So why do we think it's not that hard? Yeah, it's got X's at the front, but it's pretty long. It's not scaring anybody. I'd probably say it's just a bit sneaky. It's 2 questions in one. Okay, so we should have our books open. We should have the day's date at the top. Now, a couple of things. We go, yep, same from last time, that we can just go X times everything, right? This first one here times everything in the second bracket. And then we're going to times everything in that bracket by the -2. So you can just go through that every single time, or there is a shortcut. Yeah, Arlo, do you remember? Yeah, what was the shortcut? Yep, X times X, you get the X squared. Yeah, so your shortcut can be, what's -2 plus 3? 1, so I already know in the middle it's going to be 1x. Okay, and then it finishes off by 2 3s. Now negative times a positive is a -6, so I can do that shortcut. But if it's a long weekend, if you're sort of going, right, then you go long-winded. So X times X is the X squared, X times 3 is the 3X. We've got -2 times X is -2X. A negative times a positive is a minus. 2 3s are 6. Now when you gather your like terms, you can see, bang, you get the same answer. So if Arlo remembered and he was pretty confident, he doesn't have to have that line in there. Right? We happy with that? If you're looking at that and going, oh no, I can't skip straight to this line, then don't. Do your normal expansion. It'll work every single time. It's not like it's taking 10 minutes. We understand that? All right, here comes the little thing, and it's not hard. It's just don't be sloppy. Be careful. So when we've got this minus, you are minusing all of this expansion. So when you do it, Evie, you've got to have a big bracket that's going to have your whole expansion in that. Does that make sense? And then you just do your normal expansion. So we go X times X is X squared, right? You could do the shortcut if you wanted to, but I'm going to go the long way. X times 2 is 2x. Then we go underneath, -1 times x is -x, a negative times a positive is a minus, and 1 times 2 is 2. Right? Tidy up. I'm going to keep my big brackets around it because remember, I'm subtracting the whole thing. Oui? 2x, take x is 1x, and then I've got my -2. And here comes the crunch. It's x squared plus x, take 6, and I'm minusing all of this. So it's minus x squared. It's minus, right? What's a negative and a positive? A negative. What's a negative and a negative? Positive. Now, if you didn't have those brackets there, you wouldn't have had these changed signs, and you would have got the question wrong. So somewhere in your book, you need to make sure that you've got this little star here, or a little note to yourself that you've got to make sure that you put brackets around that so you don't stuff your negatives. Okay? And of course, we just tidy up at the bottom. Oops. And we've got 1x squared plus another x. Oh, no, we haven't. We've got x squared, and then where? Bless you, minusing x squared. So those are going to cancel out. We've got an x, take another x, that cancels out. So you're left with, what's minus 6 plus 2? Negative 4. So all of that, blah, simplified down to, bang, minus 4. Quite nice. Oui. So give you 5, let's say give you a couple of minutes. Can you please either check your day map? You're doing this, it's a little bit hard to read. Or open OneNote and you can see it easily there. If you have done that, have a think. This is what we're going to go through in a minute. Or we're doing our review. Set 5, page 99. But everyone's got something to do for now. Is that all groovy? Thank you. Yeah. Oh, here's one bracket times another bracket. They might try and just put it in a different format, but it's the same thing at the end of the day. All right? So for each of the following shapes, write down the area in factor form. So it's saying you don't have to bother expanding. So for this one, how do we find the area of a rectangle? Length times width. Okay? So in my case, what is my length? What is my width? What's the length of this rectangle, Blake? Good. And 4x tack. Does it matter? Would it matter if you switch them around the other way? No. 3 times 2 is the same as 2 times 3. Okay? Simples. What else is a little bit different about this one? Devon? Oh, so what do you think the M stands for, yeah? Meters. So we're not going to put that as part of our answer. What else is a little bit different? 2 variables. So instead of having an x plus just 3, it's a 3y. And we go, ooh. But we go ahead and we do it exactly like we would do before. So we're going to go x times everything in here. So what's x times 4x? Well, we've done that every day of the week. 4x squared. Fantastic. And now, what's x times minus y? How can we write that? So you could absolutely write minus yx. Are you going to be offended if I write minus xy? Right, because it's in alphabetical order. So you could by all means write yx. I'm writing xy. Then what do? You do the underneath. Ooh. What's 3y times 4x? Devon's all over this, yeah? So do your numbers first. 3 4s, absolutely. And you're happy that there's a plus there? Because it's a positive times a positive. So 3 4s are 12. And then, yes, y times x. So again, I'm writing xy. But if you wanted to write yx, go for it. And then the last one, we've got a positive times a negative, which means negative. And what's 3y times y? 3y squared. So it looks ugly, but it's not that bad. Okay? Is that it? So you've got to ask yourself, can I gather my like terms? So there's only the one lot of 4x squareds, but I've got a minus xy plus 12xy. So how many xy's have I got? Sorry? Excellent. 11 xy minus 3y squared. So reasonably hard, but same process. Are we happy with that? Oh, well done. If you want to put meters squared, excellent. Excellent. I'm going to add a little bit to it there, because this would be me being a little bit evil. What if I said, can you find an expression for the perimeter? Yeah. So you can get your gear, come and sit up the front, please. Okay, perimeter of a rectangle. Tell us. Oh, Devon's doing a lot of the hard work today. Yeah, Jensen? Okay, so we're going to go length plus width. Is that it? Okay, so you can either add another length, add another width, or, as the front row has said, you can times by 2. Okay, so perimeter, distance around the outside, round the outside. So we're going to say x plus 3y and we want to tidy that up. So you go a step ahead of me, please. If you have finished that, I want you to think about, what does the last question mean? Discuss any limitations on the value of x. So I'll just give you a moment, you see. So hopefully you've got that. As we're reading the language, it's pretty important that you do. So part 1 says, write down the area in factor form, because that's what we're about to do tomorrow. We're actually going to say, if I've got something in expanded form, could I put it in the factored form? I mean, I'll be honest with you, this one, there's no way, Jose, that we would put it back in the factored form. This is factored. Expanded would then be, we just times through by that number. Okay, so a little bit of language, what we're going to do. Discuss any limitations on the value of x. What does that mean? Zen, thanks. Talking to the class, you're paying attention. So limitations on the values of x. I'd say on x and y. What do we mean by that? What does limitations mean? Silence from the class. Think English, come on. Limitations. It's not a trick question. Think of any value that x and y maybe couldn't be. Like, x could be 10, y could be 2, couldn't it? Yeah? Whack it in there, it would work. What about x? What if we said x was 1 and y was 10? Would that work? I'm saying it wouldn't. Why? Consider this. If x was 1 and y was 10, what would this width end up being? 4 times 1 minus your y value. What's that? Minus 6. So can you actually go and draw minus 6 centimeters? Sorry. Can you? Sorry. So we'll ask again, can you actually draw minus 6 meters? No, you can't have a length or a width being a negative value. So again, when we're doing things, we just don't go blind Freddy, just do what the calculator says or just follow the process. You actually have to think. If we're looking at this length here, x plus 5, could x be 1? Yep, 1 plus 5 is good. Could x be minus 1? Yes, because minus 1 plus 5 is 4. That works. So what values couldn't it be? Couldn't be minus 6. Could it be minus 5? No, because then you'd have a dot. Yep, so we'd say here, like x plus 5 has to be greater than, do you remember your greater than values? Symbols, greater than 0. Similarly with this one, we'd have to say 2x take 1 is greater than 0. So it has to be bigger than. So just think about some of those things. That's where I can make a question a little bit trickier. Anyway, okay, when we're looking at this one, I'm going to leave you to have a think about the area for that, but who can remind me, what is the formula for area of a triangle? Right, so its area is a half base times height. You do not have to work out the perimeter for that one because that would be a little bit too cray-cray. Why? What would you need to do to find the length of that? Yep. Pythagoras would need to be used, and I'm not going to make you do that because that would be crazy. So with this, with B, can you just find an expression for the area, and I'll put it up. Yeah, please, if you're choking, go get water. Okay?